Hey class, in today's lesson we're going to talk about multiplying and dividing radical expressions, which is found in section 6-2, part 2 of your book. We're going to actually just divide rational expressions in this PowerPoint. Alright, so in example 4, we are going to practice dividing rational expressions. We have two examples here. So here's the deal. When dividing rational expressions, just like when multiplying rational expressions, you have to be sure that they have the same radical, or excuse me, not the same radical, but the same index. And once you determine that they have the same index, you can just basically put them together. So in this first one, I realize that the index is 2. So since it is 2, 18 is 2 and 9 is 3 and 3. So that's 2, 3, 3, and 5 x's over 2 and 3 x's. Now before we start pairing, what we generally want to do is get rid of the like terms first. So I have 3 x's in common and 1, 2. Now I pair. So I have a pair of 3's and a pair of 2's. Notice their position. They are located in the numerator, so they will stay in the numerator as a final answer. So that final answer would be 3x over 1 or just 3x. Alright, let's look at the second one. So once again, we notice the index, it's a 3, so everything's good to go. 162 is 2 and 81. 81 is 9 and 9, and we know 9 is 3 and 3. So this is going to be 2 and 4 3's, and then 5 y's over 1 3 and 2 y's. So if I cancel what they have in common, and then I circle what they the pairs, it looks like in the numerator's position I can take out a 3y, and then I am left with, and this is cube root, so don't forget that, and then I'm left with a 2, a 3, and a y. So that leaves me with 6y on the inside. And again, that's in the numerator's position, so we would leave that in the numerator. And we're done. Alright, so if we try one again, once again we need to be sure that the index are the same. They are. So 50 is 2 and 25, and we know 25 is 5 and 5. So that's 2, 5, 5, 6 x's over 2 and 4 x's. Alright, we share a 2 in common and 4 x's, so 1, 2, 3, 4. And then pair up what's left over. Notice they're in the numerator, so our answer is going to be 5x. Let's keep going. Alright, so in example 5, we're going to rationalize the denominator. And in order to rationalize the denominator, we basically are trying to, or what we'll basically have to do is get the radical out of the denominator. So we are left with the cube root of 5x squared over the cube root of 12y to the 5th z. Okay, let's break that down, just the denominator. 12 is really 3 and 4. And 4 is really 2 and 2. So we have 1, 3. I'm just going to write this here. We have 1, 3. We have 2 2's. And then we have 5 y's. And we have 1 z. Now in order to rationalize properly, we will actually need to multiply by what this is missing so that we can do even triples when it's time to factor or simplify that part. So in order to have even triples, I need to multiply by the parts that are missing. So what I'm missing for each factor, the 3, I'm missing 2 3's. I'm missing 1 2. I have a set of 3. I need 1 more y, and I need 2 z's. So everything in blue is what I'm going to multiply both the numerator and the denominator by as a cube root. So I'm going to multiply by 1 2, 2 3's, 1 y, and 2 z's. So again, 1, 2, 2 3s, 1 y, and 2 z's. All right, the denominator at this point becomes very simple because we should be able to clearly see that I can take this out as a triple, this, that one, and that one. So this becomes 6y squared z as my denominator. But it's the numerator I need to deal with now. So remember, the cube root of 5 is just 5, so I'm going to combine that with my other number. So that's 1, 2, 2 3s, 1 5, 1 y, 1 x, or 2 x's, 1 y, and 2 z's. Alright, and since this is cube root, I'm looking for triples, but in this case I don't have any triples in my numerator, so I'm left with the cube root of 2 times 3 is 6, 6 times 3 is 18, or let me go the other way, 5 times 3 is 15, 15 times 2 is 30, and 30 times 3 is 90. So this is 90 x squared y z squared over 6y squared z. And that is our final answer because there is nothing on the outside of the radical sign that we can simplify the 6 with. So this is our final answer. So again, the whole point of rationalizing is you want to separate your fractions first, and then, or separate your radical first, and then after you separate, you want to write out everything that's in your denominator and add on what it's missing to make it a perfect root, and then that's what you multiply both the numerator and the denominator by. So let's practice the next one. Alright, so this one's already separated for us. That's really nice. Alright, if I write out the factors for the denominator, that's 1, 5, and 2 y's. Notice this is cubed root, so we need 3's of everything. So I need 2 5's and 1 y. So I'm going to multiply this by the cube root of 5 times y over the cube root of 5 times y. So for my numerator, I'm going to have the cube root of 2 5's, 1 7, an x, and a y over the cube root of, and I'm just showing you to prove to you that this works, but we have 3 5's and now 3 y's. So we've done exactly as we wanted for the denominator. The denominator is just 5y. But the numerator, there are no triples. So this is going to be the cube root of 7 times 25. Let's see, that's going to be 150, I believe. So that's 150 xy. Is that right? Nope, 175. Sorry. So 175 xy. And we are done. All right, guys. So again, if you have any questions, please be sure to check with me for tutoring.